Look at this line. Dozens of people pressing in, empty containers in hand, waiting for a single deli-jawboard tanker. This is the daily reality of water access in major parts of India right now. The numbers behind these lines are grim. We are looking at a 126-year low for June rainfall, leaving the entire country with a 64. The natural weather cycles have pushed the country's water supply to a razor-thin margin. When survival depends on the next cloud, every drop of water left in the system is heavily scrutinized. When a natural crisis hits this level of severity, the search for a human cause begins. There is a desperate need to find a person, or a policy, to blame for the dry earth. Recently, attention has turned toward a major government initiative, replacing standard petrol with a greener alternative by blending it with ethanol. Almost immediately, a massive claim started tearing across social media. According to these viral posts, manufacturing a single liter of this new ethanol fuel consumes 10,000 liters of water. If the math holds, the government's push for green energy might be directly responsible for the drying reservoirs. To find out, we need to trace the actual industrial supply chain. Let's look at exactly what happens when you create ethanol from first-generation crops like rice. This flowchart breaks down the baseline physical input. On one side, we have roughly 2.5 kilograms of raw rice. Run that through the processing pipeline, and it converts into exactly 1 liter of ethanol. Now look at the actual water required to run that specific chemical conversion. The fermentation and processing at the factory only consumes about 5 liters of water. 5 liters. That is a vast gap from the 10,000 liters currently circulating in these social media reports. The discrepancy comes down to a basic mix-up. These claims are taking the water used to grow the crop in the field, the agricultural footprint, and counting it as the industrial footprint of the ethanol factory. True, growing 2.5 kilograms of rice in a field requires thousands of liters of water. Agriculture is deeply water-intensive. But India has been planting, harvesting, and refining massive quantities of rice and sugarcane for centuries. These crops were in the ground long before anyone drafted a modern fuel mandate. The ethanol industry is mostly utilizing surplus agricultural stock that was already grown. In many cases, it's actually providing a financial lifeline to struggling sugar refiners rather than forcing new crops into the soil. Look at this comparison. Blaming ethanol processing for the water used to grow rice is like telling someone they drink 10,000 liters of water a day simply because that's how much water it took to grow the cotton for the t-shirt they're wearing. Yes, farming takes water, but fixating on the factory processing of ethanol is a mathematical distraction. It keeps us from looking at a much larger, very real threat that is quietly arriving right now. While public outrage currently targets our agriculture, a massive, silent, high-tech industry is rapidly expanding across the entire country. A modern AI data center is a massive warehouse packed to the ceiling with graphics processing units, or GPUs. This schematic illustrates their core engineering bottleneck. Processing artificial intelligence generates extreme heat. To prevent hardware failure, these chips require massive, continuous flows of liquid water across heat sinks to cool them down. When you scale that up to a hyperscale AI facility, the volume of water required is significant. A single data center can consume between 2 million and 20 million liters of water every single day. Put simply, keeping just one of these buildings cool takes enough daily drinking water to sustain a town of 5,000 people. The thermal footprint of AI is so immense that global tech giants are literally redrawing maps to find natural ways to keep their servers cold. They are testing extreme solutions, like sinking sealed data centers to the bottom of the ocean or building them in the freezing Arctic, all to save on the cost of pumped water. Yet massive foreign investments are funding the construction of these hyperscale hubs right here in India, a country already grappling with severe natural water deficits. And the hardware is only part of the equation. The electricity required to power these hubs relies heavily on thermal coal plants, which consume vast amounts of water to generate the steam that spins their turbines. Securing India's water future requires looking past flawed agricultural rumors and addressing how the nation will meet the physical water requirements of the AI revolution.